This is Lab 1, looking at constant velocity. I recorded the video for this using Screencast-O-Matic and took the video of my experiment on my iPhone. Any noise that you may hear in the background is because of the motor/battery in my laptop, and I apologize for the sound quality not being as good as it could be. Alright, so with this video, we were observing the motion of an object. I chose a toy car moving at a constant speed. I placed this car on the floor of my classroom next to a meter stick for scale. Once I recorded the video, I then compared my experimental data with a computer model made in VIDLE. The experimental data I got out of using the tracker program to analyze my video. Here you can see the motion of my vehicle. The main physics concept that we are testing here is Newton's second law. And this is applied by looking at an object moving at constant velocity. This object has a known mass, and the data is taken for a certain time period. When we're looking at Newton's second law, we're looking at final velocity being equal to the initial velocity plus the net forces divided by mass times change in time. When you look at my experimental data versus the computer model data, you'll see that they match quite closely, especially up until the 0.4 second mark. They're actually pretty much identical. The variation that occurs after that, I believe, may be due to some difficulty pinpointing the center of the car using the tracker program, and also the possibility that the car may have been drifting slightly to the side as it traveled, since I was taking the video from the side I couldn't see above if it was in fact drifting a little bit, but I believe it may have. In the VIDLE program, to initialize the program, I first had to look at initial position of the car, its initial velocity, as well as the amount of time that I observed it, which ended up being about 1.767 seconds, and also taking into account the mass of the car. All of that information was inputted into the program to make the model specific for my data. The model was also adjusted to include the correct method of computing velocity. I believe that my data illustrates Newton's second law as seen in the results that I got in my graph for both my experimental data and the computer model. I believe that my results were pretty close to what I expected them to be. If I were to flip the axes around in the tracker program, it would change my results. The initial position of my car may have been changed slightly, and that would have affected my results on the graph. In terms of pushes and pulls added together to give a zero net force, there would be two of those coming from the left-hand side and also from above. And the motion of the car doesn't change as it travels, which lets us know that there is in fact zero net force on it. I believe that my results again illustrate Newton's second law and is an excellent example of an object showing a constant velocity